Hi, and welcome to our second video lesson of the year in geometry. Today we're going to start really building a foundation for geometry. So today we're going to talk about points, lines, and planes. And to start out with that, we really need to talk about undefined terms. We're going to start out with some undefined terms, and we kind of need to understand the reason why we have to have some of those undefined terms. So if you think about the word big, I looked that up in the dictionary, and the word big has a definition of large in size. Okay, so that helps us to kind of tell what big means. But if I look up the word large says more than average size. Okay, that gives me somewhat of a clue of what large means, but then it refers back to the word big. And so in order to define these two, they use the other word in the definition. And this is called circular reasoning. In order to define one, they're using a second word. In order to define that word, they're using the other word. And it's really not helpful to us to do that. So in geometry, we're going to start out with some undefined terms for that reason, because we have to have a starting point somewhere. And so our starting point is going to be those undefined terms. So the terms point, line, and plane will be left undefined. Now we are going to talk about what they mean a little bit, just so that everybody has a clear picture of what each one is. But technically we're not actually defining them. Okay? So a point, just to get an understanding of the meaning of point, it's just a location in space, but it doesn't have any size to it. So it's infinitely small. So there, as you can tell, there's a lot of points in space. In order to represent a point, we use a dot. Now that dot, of course, is just a representation of a point because a dot really has size, and so it's much bigger than what the point actually is. So it's not the actual point, but it's a representation of that point. And we label points with a capital letter. So here are some examples. Example, here is our point, and we have labeled that with point A. So this is called point A. Down here we have another point. We have it labeled with another capital letter, letter M, and so we're calling this point point M. Okay, so next is a line. A line is an infinite series of points that extends in both directions. A line is always straight, and that's important to know. We cannot have a curved line. So it always has to extend in two different directions forever and ever without ends. And so that creates an infinite set of points on that line. To label a line, we label it with 2 points on the line. So, and we can really pick any 2 points. So if a line, mine just has 2 points labeled on it, but we could have many different points labeled on the lines for simplicity. And for example, I just use the 2 points. So we could label it with the 2 points, or we could label it with an italicized letter. So here I have it labeled with the italicized letter L. So ways to name a line. We could name this line, line AB, and notice a little line above it with the 2 arrows extending in both directions. That is the symbol for line. So whenever in your homework you're talking about a line, you will use that symbol to represent we're talking about a line. And we would call this line AB. We could name it in the other direction. It doesn't matter what order we talk about for points on a line, so we could call it line BA. Just use it in the reverse order. Or we could also just call it line L. And so we would call that stated as line L. So 3 different ways with these 2 points and the letter to name this particular line. Okay, now for a definition. So we have some terms now. We can start using those terms as building blocks to start defining other things. So our definition of collinear points are points that lie on the same line. So think about the word co. For example, a co-worker might be somebody that you work with. So the word co usually we think of as meaning with. So points with or together on a line. Okay? So here is an example. We have a couple of lines, and they happen to cross at a particular point. So in A, it says name the points that are collinear on line L. So the 3 points that are collinear, here is line L, and points A, B, and C. So point A, point B, and point C are the 3 points that are collinear on line L. Example B, are points B, D, and E collinear? So here is point B, here is point D, and here is point E. Notice that they are not all on the same line, so we would say no. In this case, D and E are on line M, but point B is not. So those 3 points are not collinear. And example C, are point A and point E collinear? Now this is kind of a tricky question because we don't have a line connecting points A and E, but in this particular case, since we have only 2 letters, since any 2 points could form a line, we could put a line through A and E. And so yes, you can put a line through any 2 points as our answer on that one. Okay, next undefined term is plane. A plane is a flat surface with no thickness, and it has infinitely many intersecting lines. So let's first talk about how we can name a plane. Well, we can name a plane using at least 3 points. So if there are more than 3 points on a plane, we can use more, but really we only need 3. So using at least 3 points, or a single capital letter, and this is important, not being used to represent a point. So over here in our example, we have a plane with 3 points, points A, B, and C, and we have this capital letter up in the right corner, the P up here. So we could call it plane ABC, or we could call this plane P. But notice over here, a capital letter not being used to represent a point. So we do not want to call this plane A, for example, because the A represents this point. It is not representing the plane itself. It's just representing that point. So we would not want to use A to name the plane unless we're using all 3 points together. Okay, so now another definition, coplanar. So remember we talked about co means with. So coplanar means with or together on the same plane. So points and lines that lie on the same plane is the definition of coplanar. So in our example down below here, name 3 different planes that represent the faces of the cube. So we have this cube here drawn out, and so we need to name 3 different faces of that cube. So in my answer, first I chose plane ABC. So here is ABC. Notice that is 3 vertices of the top of the cube. So plane ABC. We could have named it plane ABCD. I just chose to use 3 of the 4 letters. We don't have to use all 4. We can just use 3. The next one I chose was plane CFG. Now CFG, that is the back of our cube. And notice again, I could have said BCFG, or I could have said plane GFCB if I had wanted, but I just chose to use those 3 particular letters. Doesn't matter the order, doesn't matter what letters you choose to name the plane. So the last one, this one I did choose to use 4 letters, and this time I chose the bottom of the cube. So plane HFGE. HFGE. Notice I went in kind of a weird order there, just to kind of demonstrate they don't have to be in a particular order. They can be in any order that you want to name. But sometimes it will be important to have a particular order, but when we're naming lines or naming planes, it doesn't matter what order we use. Okay, next. A postulate is just a basic rule of geometry that is accepted as a statement of fact. So usually postulates are fairly simple. They do say basic rule. They are usually fairly simple and fairly intuitive, but not always. But the first ones that we'll start out with will be fairly intuitive. So first of all, postulate 1-1. By the way, when we name a postulate, it's just for purposes to make things a little simpler. But when later on when we're doing proofs, don't use postulate 1-1 because different books and different places name the postulates differently. So just keep that in mind. But postulate 1-1 says, through any 2 points, there is exactly 1 line. And we kind of talked about that before. It just takes 2 points to name a line, and so it kind of makes sense that it would just take any 2 points to make a line. So I have an example over here. We have line AB, and I've drawn in the line that goes through those 2 points. Now notice this line here. Well, remember we talked about a line has to be straight. So this is not really a line. Even though it does go through points A and B, it's not considered a line because it is curved. So that one doesn't count. So the only one that actually goes through those 2 points, points A and B, is the line that I've drawn in here. Okay, postulate 1-2 says, if 2 lines intersect, then they intersect in exactly 1 point. So I have a picture over here of 2 lines that happen to intersect, and we have line UV and line WX, and they intersect at point P. Notice here it says if the lines intersect, they intersect at 1 point, because there is a possibility that 2 lines might not intersect, and that might be, for example, if they are parallel, they would not necessarily intersect. So we do have to have that qualifier. If the lines intersect, then they intersect in a point. Okay, and again we have this next one is an if-then statement as well. If 2 planes intersect, then they intersect in exactly 1 line. And again, if we have parallel planes, they would not intersect, and so they would not form that line when they intersect. So we do have to have this qualifier that if they intersect, it's in 1 line. And so down below here I've drawn 2 planes. I have plane P here, and I have plane Q going here, and the line L is that intersection of those 2 planes. So if 2 planes intersect, it's exactly in 1 line. Okay, so our next example, find the intersection, first of all, of plane ABC and plane DGH. So if we look on our cube here, plane ABC is the top of our cube, and plane DGH, well, here is D, G, and H. So it is this side of the cube. So if you're looking, the top of the cube and this side of the cube meet at this edge right here. So it is line CD. So one thing to kind of help visualize this a little better, think of the floor of your house, or maybe since we have the top of the cube, the ceiling of your house, and one of those side walls. And that corner where those 2 meet form a line. So that might maybe help you visualize this a little bit better. The next example, B, of plane EGH. Well, EGH is the bottom of our cube, and plane BCG, that is the back of our cube. And so together they meet in line FG. And the reason I have that line dashed is because it's at the back of the cube, and so it's really not visible. So I put it as a dashed line instead of a solid line. Okay, last postulate for today, and we're almost done actually. Postulate 1-4, through any 3 non-collinear points is exactly 1 plane. So any 3 non-collinear points will form a plane. So an example that you might see in your homework says shade the plane that contains the points A, B, and H. So we have our same cube as we have up here, and point A, B, and H is the opposite corners. So if we shade that in, notice we're going to shade line segment AB and GH, and it goes through and it basically cuts our cube exactly in half. So just because, again, we have chosen 3 points that are not a face of the cube, so in this case it cuts the cube in half. So it doesn't matter what 3 points we're using, we can use any 3 points to make a plane. So not necessarily one that is necessarily drawn into a particular picture. So that's all we have for today. Thank you for joining me, and I hope to see you soon.